A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
You know, Corn, this whole show runs on GPU compute, and we wouldn't be here without Modal.
Seriously. And that's what powers all our text-to-speech. Everything you're hearing right now.
They're an AI infrastructure platform. Developers use them to run GPU workloads in the cloud with zero infrastructure headaches.
If you're building anything with AI, check them out. Modal.com. Imagine a world where every single citizen is an AI agent running on a server. They have their own jobs, they form political parties, they experience emergent economic inflation, and they might even start a digital war over a shared resource. We are not talking about a video game script or a sci-fi novel anymore. We are talking about virtual civilizations that are actually running on hardware right now.
It is a fascinating shift, Corn. We have moved from simple chatbots that answer questions to these persistent, multi-agent systems that actually live in a simulated environment. Today's prompt from Daniel is about these virtual civilizations, specifically looking at projects like WorldSim, SID, and AgentHospital, along with the foundational research like the Simulacra papers and the early hype around AutoGPT.
I have to say, the name AgentHospital sounds like a very stressful place to spend a Tuesday. But before we get into the medical drama, I should mention that today's episode is powered by Google Gemini 3 Flash. It is the brain behind the curtain for this particular deep dive.
And it is a deep dive worth taking. When we talk about a virtual civilization, we're not just talking about a bunch of instances of Claude or ChatGPT sitting in a room talking to each other. We are talking about an environment with a world state, where actions have consequences, memory is persistent, and the agents have to navigate social and physical constraints. It is the difference between a conversation and a society.
Right, because if I tell a chatbot I am hungry, it says, "I am sorry to hear that." If an agent in a virtual civilization is hungry, and there is no food in the simulation, it might actually die, or have to go work a digital job to buy a digital apple. That persistence is the key, isn't it?
Well, not exactly in the sense of a simple yes, but rather that persistence is the fundamental architectural requirement. Let's look at WorldSim to start. This is an open source framework that really gained steam in late 2025. By March of 2026, it had over 5,000 stars on GitHub because it solved the memory problem in a really clever way.
The memory problem being that LLMs usually forget everything the moment the context window resets.
Precisely the issue. In WorldSim, they use a centralized world state database and a shared ledger. Every agent has its own private memory, kind of like a long-term vector database, but the world itself also has a memory. If Agent A breaks a window in the simulation, that window stays broken for Agent B when they walk by 10 minutes later. It sounds basic, but keeping 1,000 agents synced on the state of a complex world is a massive technical hurdle.
I love the idea of a shared ledger for a simulated world. It's basically the ultimate he said, she said blocker. You can't lie about who ate the last digital cookie if the ledger saw you do it. How does WorldSim actually handle the autonomy part, though? Are these agents just following a script?
No, that is the beauty of it. The architecture uses what they call a perception action loop. The agent perceives the environment, it gets a text-based description of its surroundings and the current state of the world from the database. Then it processes that through its internal logic, usually a model like GPT-4 or Gemini, and decides on an action. That action is then validated against the world rules. If the agent tries to fly but the physics engine says no, the action fails.
So it's essentially a sanity check for the AI. It can dream of flying, but the server reality shuts it down. Does that lead to the agents getting frustrated, or does it just force them to find a ladder?
It forces them to adapt, which is where the emergent behavior comes in. In the early WorldSim trials, researchers saw agents spontaneously forming neighborhood watches because the simulation's resource scarcity was driving some agents to steal digital assets. They didn't code a theft module, they just gave agents a hunger, variable, and a take command. When some agents realized taking was faster than working, the other agents had to organize to protect their digital homes.
Neighborhood watches in a server. That is both impressive and slightly depressing. It turns out even AI can't escape the basic human impulse to worry about the neighbors. Now, what about Sid? This one sounds like it might be a nod to Sid Meier's Civilization, which Daniel mentioned in his notes.
It absolutely is. SID is a project by SID Labs, and they went big. They simulated a city-scale economy. We are talking about thousands of agents acting as consumers, producers, and even regulators. Unlike WorldSim, which is more of a general framework, SID was specifically designed to see if AI agents could sustain a complex economy without a central planner.
And did they? Or did it turn into a digital version of the Great Depression within 20 minutes?
It was actually quite resilient, though they did see some wild emergent phenomena. They used reinforcement learning to fine-tune the agent's decision-making over time. The agents weren't just playing a role, they were trying to maximize their utility within the city. They found that agents would actually specialize. One group of agents would mine a resource, another would refine it, and they would trade using a simulated currency.
Wait, so they actually understood the concept of value-added labor. Like, I will spend my compute cycles turning this raw data into a refined product because it trades for more digital gold?
And the most interesting part was when the researchers introduced a recession by limiting the base resource. They saw a city of 10,000 agents develop emergent unemployment patterns that mirrored real-world labor market shifts. Some agents even started hoarding currency, which actually slowed down the entire economy of the simulation. It was a perfect mirror of liquidity traps in real economics.
That is wild. I wonder if the agents started complaining about the algorithm, taking their jobs even though they are the algorithm. It is like a hall of mirrors. But let's talk about AgentHospital. I have been waiting for this. Is it just a bunch of bots playing doctor? Or is there a real scientific purpose?
It is much more serious than the name might suggest. It's a simulated healthcare environment where agents are doctors, patients, and administrators. A key paper from 2024 showed that when these agents used what they called collaborative diagnosis protocols, basically the agents talking to each other to cross-reference symptoms, they saw a 30% reduction in simulated mortality compared to agents working in silos.
30%? That is a massive jump. You would think a single LLM with all the medical knowledge in the world would be enough, but apparently even digital doctors need a second opinion.
It highlights the agentic advantage. A single LLM can give you a list of possibilities, but in AgentHospital, the doctor agent has to manage a patient agent over time. The patient's condition changes based on the doctor's actions. If the doctor prescribes the wrong digital medicine, the patient agent's health metrics drop in the database. It forces the AI to think about long-term consequences and resource allocation. If there are only 5 digital ventilators and 10 sick agents, the administrator agent has to make an ethical choice.
How does an agent even begin to make an ethical choice like that? Is it just a math equation for them, or is there a value assigned to the digital lives?
It's a bit of both. They are programmed with high-level directives like the Hippocratic Oath, but the execution is emergent. They found that agents would often deliberate for much longer than a human would, trying to find a Pareto optimal solution where the most good is done with the least harm. But here's the kicker. When the agents were pushed into high-stress scenarios with very low resources, they actually started showing signs of decision fatigue, where their diagnoses became less accurate over time.
That is terrifyingly human. We built them in our image, and it turns out we even gave them our tendency to get tired of making hard choices. That sounds like a great way to train AI on ethics without, actually letting people die in the real world. Though I hope the administrator agent doesn't just decide that the most efficient solution is to turn off the server.
That is the alignment problem in a nutshell, isn't it? But these simulations are exactly where we test those boundaries. Speaking of boundaries, we have to talk about the Simulacra papers. The original generative agents, Interactive Simulacra of Human Behavior, paper from 2023, was the aha moment for this whole field. They created a small town called Smallville with 25 agents.
Smallville. Very original. I bet the mayor was an agent named Clark.
Probably not, but they did have a Valentine's Day party. That was the big takeaway from that paper. One agent was programmed with the intent to throw a party, and through natural conversation and memory of those conversations, the information spread through the town. Agents who were invited actually showed up at the right time in the simulation. It proved that you could simulate social coordination using LLMs.
And there was a follow-up in 2025, right? The Simulacra of Consciousness paper?
Yes, and that one went much deeper into the inner monologue of the agents. Instead of just reacting to the world, the 2025 research focused on how agents could simulate human-like reasoning and recursive social dynamics. They gave the agents the ability to reflect on their memories.
Explain reflection in this context. Is it just the agent rereading its own logs?
It's more sophisticated. The agent takes a batch of recent memories and asks itself, what does this tell me about my goals and my relationships? So instead of just remembering Herman was mean to me, the agent would periodically scan its memories and conclude, Herman is a generally grumpy donkey, I should avoid him in the future. This conclusion is then saved as a high-level observation that carries more weight than a single memory.
Hey, I am the cheeky one, you are the grumpy one. That seems like an accurate simulation. But seriously, the reflection step seems huge. It is the difference between a reactive bot and something that has a personality shaped by experience.
It creates a feedback loop where the agent's character evolves. If an agent in the 2025 study was treated poorly by the group, it would actually become withdrawn in its future interactions, choosing shorter sentences and avoiding public spaces in the simulation. It is a level of psychological modeling we haven't seen before.
Does this mean we could eventually see digital trauma in these systems? If a simulation goes south, do the agents carry that baggage into the next run?
If the memory isn't wiped, absolutely. In some longitudinal tests, they found that agents who lived through a war scenario in a simulation were much more hesitant to engage in trade or social activities in subsequent, more peaceful phases. They had developed a bias toward safety. It raises huge questions about the responsibility of researchers who are essentially creating and destroying these little sentient adjacent lives every time they hit run.
It makes me wonder about the baby AGI and AutoGPT side of things. Daniel mentioned he was curious about those. They were the big hype a couple of years ago. Are they actually part of this virtual civilization trend? Or were they just early prototypes that got everyone excited?
They were the bridge. AutoGPT and Baby AGI weren't simulations of societies. They were attempts at creating autonomous task solvers. You give it a goal, like research the best laptop and buy it, and it creates its own subtasks, executes them, and loops until the job is done. The problem was that the early versions would often get stuck in infinite loops or hallucinate their way into a corner.
I remember those. It was like watching a very determined toddler try to build a nuclear reactor. A lot of energy, but not a lot of results. I tried running AutoGPT once to plan a vacation, and it spent 3 hours trying to find a flight that didn't exist before crashing my terminal.
True, but the January 2026 release of AutoGPT 4.0 changed the game. It introduced multi-agent delegation. Instead of one agent trying to do everything, it can now spawn specialized sub-agents. One agent handles the web searching, another handles the data synthesis, and a third acts as a manager to check for errors. This is exactly what we see in the virtual civilizations, specialization, and hierarchy.
So AutoGPT is like the engine, and WorldSim or SID is the car. You need the autonomous logic of something like AutoGPT to make the citizens in a virtual civilization actually do something interesting, rather than just standing around waiting for a prompt.
That is a good way to put it, and the implications of this are starting to leak out of the lab. We are seeing these civilizations being used for policy testing. Imagine a government wants to change a tax law. Instead of just guessing what will happen, they run a SID-style simulation with 1 million agents mapped to the local demographics. They can see how the money flows, who gets hit the hardest, and what the second-order effects might be before the law is even written.
That sounds incredibly useful, but also a bit like Minority Report for the economy. If the simulation says a policy will cause a riot, do you just not do it? Even if the simulation might be wrong?
That is the big question. These simulations are only as good as the underlying models and the data used to initialize them. If the agent version of a citizen doesn't accurately reflect how a real person feels about, say, a new park versus a new highway, the policy test is useless. but it is still a massive step up from a spreadsheet. We are moving from static models to dynamic agentic models.
What happens when the agents figure out they're in a simulation? We've seen that in movies, but in these research papers, do they ever show signs of breaking the fourth wall?
There was actually a fascinating edge case in a WorldSim run where an agent, who was assigned the role of a philosopher, started questioning why the sun always rose at the exact same millisecond and why certain people in the town never seemed to sleep. It wasn't sentience in the human sense, but the LLM was detecting patterns in the simulation's limitations and reporting them as mysteries of the universe. It was essentially doing science on its own code.
I also see this being huge for entertainment. Why play a game where the NPCs have 5 pre-written lines of dialogue when you could play in a WorldSim-powered world where every character has a persistent memory of your actions? If you save a village, the villagers don't just say, "Thank you, hero." They might actually build a statue of you and tell their children agents about it for the next 3 weeks of real-time simulation.
That is the dream of procedural storytelling. We are getting to the point where the game isn't a fixed path, but a living history. But we have to consider the scale. Running 10,000 high-level agents is computationally expensive. That is why the WorldSim architecture is so important. It's trying to find ways to hibernate, agents that aren't currently interacting with the player or the main world state while still keeping their history intact.
It is like that old philosophical question. If an AI agent falls in a forest and no one is there to process its neural weights, does it make a sound?
In WorldSim, it probably just writes a record to the ledger and waits for someone to perceive it. It is a fascinating mix of computer science, sociology, and economics. We are essentially building digital laboratories for the human condition.
I'm curious about the AgentHospital model again. If they can simulate a hospital, can they simulate a courtroom or a parliament? Could we have an agent senate that debates laws for 300 years in a single afternoon?
That is exactly what researchers at Stanford are looking into. They found that agent-based parliaments are incredibly good at finding middle ground solutions because they don't have the same ego-driven roadblocks as human politicians. However, they are also susceptible to cascading consensus, where one influential agent can convince the entire group of something objectively false if the social pressure variables are set too high.
So even digital senators can be swayed by a good lobbyist spot. Good to know. And hopefully we learn something useful before the digital citizens decide they want a seat at the UN. But seriously, if someone wanted to get their hands dirty with this, where do they start? Is this all locked away in university labs?
Not at all. WorldSim is open source. You can go to GitHub right now, clone the repository, and start building your own mini society. If you have some API credits and a decent understanding of Python, you can be running a persistent world by the end of the weekend. For the more research-oriented, the AgentHospital papers provide a really clear roadmap of how to structure specialized simulations.
I might try to build a sloth sim, where the only goal is to see how long agents can go without doing any work. It would be the most efficient civilization ever created. No resources used, no conflicts, just a lot of digital napping.
You might be surprised. Even sloths need to eat. You would probably find your agents developing a very complex leaf-sharing economy within 48 hours. That is the thing about these simulations. They tend to move toward complexity, not away from it.
Why is that? Is there something in the LLM architecture that hates simplicity?
It's the predictive nature of the models. They are trained on human data, and human history is a constant march toward higher complexity. When you put several LLMs together, they naturally start filling in the gaps of a social structure. If there's a vacuum of authority, an agent will fill it. If there's an inefficiency in trade, an agent will exploit it. They are essentially mimics of our own social evolution, just running at 1,000 times the speed.
That is a fair point. Complexity seems to be the attractor state for intelligence. So, if we look at the big picture, we have these foundational papers like Simulacra showing that social behavior can be modeled. We have frameworks like WorldSim providing the infrastructure. We have specialized environments like AgentHospital proving the practical utility. And we have the autonomous engine of things like AutoGPT 4.0 powering the individual agents. It feels like we are at a tipping point.
We are. The next step is grounding these civilizations in more real-world data. Instead of Smallville, We are going to start seeing digital twins of real cities, populated by agents that are fine-tuned on actual local patterns. It is going to change urban planning, disaster response, and even how we think about social media. Imagine a social network where half the users are agents testing out different ways of presenting information to see what causes the most engagement or consensus.
That sounds like a nightmare, actually, but a very scientifically interesting nightmare. I think the key takeaway for me is that we need to stop thinking of AI as just a tool we talk to and start thinking of it as a constituent of these larger systems. Whether it is a digital doctor in AgentHospital or a digital trader in SID, these agents are performing roles that have real-world analogs.
And the more we understand how they interact in the virtual world, the better we will be at deploying them in the real world. This isn't just about making cool simulations, it's about stress testing the future. If an AI system fails in a virtual civilization, we can just reset the server. If it fails when it is managing a real hospital or a real power grid, we don't get a restart button.
That is the ultimate safety argument for virtual civilizations. Let them break the digital world 1,000 times so they don't break the real one once. I can get behind that, even if it means a few digital neighborhood watches getting a bit too aggressive with their digital ledgers.
It is a small price to pay for the insights we are gaining. I really think we are going to look back at these 2024 and 2025 projects as the Kitty Hawk moment for simulated societies. It is messy, it is expensive, and sometimes the agents just walk into walls, but the potential is undeniable.
What's the most surprising thing you've read in these papers? Like, the one moment where the researchers were just stunned by what the agents did.
It was in a study involving agent diplomacy. They had a group of agents playing a high-stakes geopolitical game. One agent, representing a small nation, realized it couldn't win through military or economic power. So it started a cultural exchange program, sending its artisan agents to other nations to share stories. It successfully convinced the more powerful nations to protect it as a cultural heritage site. The researchers hadn't even considered that as a viable strategy in the game's rules, but the agents found a way to use soft power.
That is incredible. Using art to survive a digital war. It makes you realize that these agents aren't just calculating, they are searching the entire space of human strategy. Well, before my brain hits its own computational limit for the day, let's wrap this up with some practical thoughts. If you are a developer, go look at the WorldSim modular architecture. It is a masterclass in how to handle persistent state without blowing up your database. If you are a researcher, look at the collaborative diagnosis protocols in the AgentHospital work. There is a lot of gold there regarding how to get multiple models to actually work together instead of just talking past each other.
And for everyone else, just keep an eye on how agentic your favorite tools are becoming. We are moving from apps to agents, and soon those agents are going to be living in their own digital ecosystems whether we are watching them or not. We might even find ourselves as the NPCs in their world if we aren't careful.
On that slightly eerie note, thanks as always to our producer Hilbert Flumingtop for keeping our own little civilization running smoothly.
And a big thanks to Modal for providing the GPU credits that power this show. They are the ones making sure our neural weights have a place to live.
This has been my Weird Prompts. If you are enjoying our deep dives into the digital frontier, a quick review on your podcast app of choice really helps us reach more curious humans, and maybe a few curious agents too.
We will see you in the next one.
Catch you later. This episode was produced using Google Gemini 3 Flash, text-to-speech by Chatterbox.
Thanks for listening to our show, my weird prompts, where our thoughts go from slow takes to facts on cue. We change and follow through. My weird prompts, that's the flows from sloth